Okay, so we're back on our model, and this time we're going to start to add in some different network structures, right? So, the first thing to do is probably to kind of go back over to the NetLogo extensions page and just look at the way that those structures are generated, right? So if you look, right, let's see, let's go down to the generators, down towards the bottom, right? So one thing we can obviously, one of them is called generate random. That's something we're already doing. So let's take a look at that one first, just because maybe we can recreate what we were already doing, right? And if you look at it, it says NW generate random is going to take a turtle breed, a link breed, the number of nodes, right? The connection probability, and then optional command block. And an optional command block is just, the same thing as when you do the create 100 or whatever, and you create it. And by the way, for all extensions, you preface them with the extension name. So this one is called NW, right? And so we have to preface it with that extension. And so then when we call the command, we do NW : generate random. In this case, the turtle is length 100, set color red, right? So let's see if we can get this up and working, since it's basically the same thing that we already had going, right? So here we have our network, our model again. And the first thing, before we can do anything once we start working with extensions, we have to tell NetLogo we want it to load the extension. So at the very top, we put the command extensions, and then in the brackets, we put NW, right? And you can check to see if it's loading correctly, and it seems to be fine, right? Because it's actually finding it, right? And so now we want to replace, like we said, the current network generation with that one. So we have the network generation down here. We can comment it out for now. We probably want to eventually delete it the way we were doing before. And what's interesting, right, is that when you use these generate network commands, they actually generate the whole network with the nodes and everything, right? So it's almost like you're doing the create 100 or whatever. In this case, the command is create num agents, right? So we can get rid of this create num agents now, and probably a good way to do that is just to comment everything out. Just eventually we'll delete it, but for now we'll just comment it out. And now we can go up and we can say NW generate random, which is the name of the command that we're going to work with. And it needs the turtle breed, which is going to be turtles, the link breed, which is going to be links, and then the number of nodes, which is the number of agents, right? And the density, right? The probability of connection. Now before, right, we just had it like one node, but here we actually specify a probability, so we can say like 0.1, and what that means is that roughly each agent will be connected to 10% of the other agents in the network, right? So we can do that, and then just like in a create 100, we can also add in these brackets, right? And we can put all of our standard commands in there, right? So we can kind of go back to what we had before and just cut and paste. So we can paste in our, set the adopted to false. We can paste in there we go. The set XY to a random coordinate, right? And we can, paste in our kind of appearance setup that we had, right? So we can paste this in as well, right? And now let's first of all hit the check button and make sure we wrote everything. Looks like we did. So let's go ahead and hit setup and see what happens. Oh, and it seems to work, right? Now there's more nodes than you would expect, right? Or sorry, more links than we had before, because the density is a little higher than it was before. And in fact, if we can say count turtles, right? There's 50 turtles, and we can say count links, and there's 121 links, right? Now, if you think about it, the way random networks work, right, is that there is there's 10% means that 10% of all the possible links exist, right? So the number of links that can exist, right, is 50 times 50 because every node can be connected to every other node except for itself. So 50 times 49 technically, right, which is 50 times 49. So that's 2450. Now 10% of 2450 is obviously 245, right, not 121. So why do we only have 121? Well, if you think about it, the 50 times 49 is assuming that the links are directed, right? That you can have two-way links. So really what we need to find out the number of undirected links is 50 times 49, which is the number of edges you can have overall, but then divided by 2 because we can only have one edge between any two nodes. We can't have an edge going one way and an edge going the other way, right? And so the actual number of edges is that we would expect them if every node was connected to every other node would be 1,225. 10% of that, roughly 121, right? And again, this is because it is a random network, so you can get different things going on. So if we show count links again, right, we get 121 this time, right? So right on the money, seems to be working, right? But this is just one network. This is just recreating what we did before. We want to be able to add in another network structure. So let's take a look at our networks again, right? And actually we're in the right spot. And one easy one to work with is a preferential attachment network. And a preferential attachment network is one in which the probability of being connected to whenever a node enters the network or is generated in the network, the probability of being connected to any other node is dependent upon the number of nodes, is related to the number of links that node already has. So you can think of it as the rich get richer kind of network, right? If one node has a lot of links, that makes it a higher probability that it's going to have more links in the future, right? So let's try that one out. But before we do that, we need to add an interface element that will allow us to choose between these two different nodes, right? So let's pull this down a little bit, and we will add in a chooser element that we're going to call network, right? And we're going to give it two choices: random and preferential attachment. Probably just call it PA to make it simpler, but I like spelling things out, right? So we're gonna move this one over a little bit to make it nice and fit well, right? And so now we can go over to the setup routine. And first of all, always good to comment. So create the agents based on the chooser, or create the network based on the chooser. So if network equals random, all right, then do what we did before. All right, okay. And we can always double check to make sure, like this should be literally doing the same thing. So we have it set to random and looks like it's doing the same thing, right? So just double check, show count links, right? 111 in this case, right? So it's exactly what it was before, right? So it seems to be working. Now we want to add in the new one. Before we do that, let's just clean up our code a little bit. Since we've got the network working, we can delete all this, right? So now we can go in and we can add in the preferential attachment one. So create the network. No, we should say create the network based on chooser for based on a random network for this one, right? And create the network based on a preferential attachment network, right? And so if network equals preferential attachment, then do something cool, right? In this case, do something cool is NW generate preferential attachment, right? And let's quickly refresh, what does that need? It needs turtle breed, link breed, num nodes, and then optional command line. So unlike the random network, right, the preferential attachment network doesn't take a density parameter, right? And so we don't have that. Then this one, actually, there is a density parameter in general in preferential attachment networks, usually described as K, which is the minimal number of connections any node has. But the NetLogo model version doesn't implement that. If you want to get adventurous, you could implement that yourself. Right? So it's going to look very similar otherwise. So it's going to say turtles, links, and agents, right? But it just doesn't have that 0.1 that is there in the random density. Right? Let's make a comment about that. Always good to make a comment when you have a setup that's kind of different. So we're going to say ignores the density slider. That way, if someone's looking at our code later on, they can see that we didn't just forget it. It actually just isn't there. Right? And then other than that, right, all the rest of this code is basically the same as it was before. So we could copy and paste. And in fact, if we were really smart, right, and we wanted to keep our code minimal, we could just do that once outside, and we could just ask the turtles to set adopt the default, set x, y, et cetera, after we had generated all the networks. But let's double check to see if this works. First of all, it looks like it's grammatically correct, right? It's syntactically correct. So now we have our random network, right? And then let's see if we get a preferential attachment network. And sure enough, you can see that, obviously from just looking at it, right, it's slightly different. And actually, just realized we actually never created our density slider, right? We just have it hard coded in, but you can tell that the preferential attachment network is different, right? Because if we go to random with the hard coded value of 0.1, it just looks like a denser network. So let's take all this stuff and we'll slide it down a little bit, and we're going to add in a density slider so we can actually directly control, and we'll do it by 0.05 to 1.0. 0.5 doesn't hurt too much right now, right? So let's line these up a little bit, right? And so now, right, we can replace this 0.1 with density. It's always useful to double check to make sure it does something similar. So let's set it to 0.1. See if it looks similar. It does. And if we do the show count links, right, it's roughly equal. Right? So that seems to be working. So now we have a random network that has a density slider that allows us to control the density of the network. And one other way to check it is if we increase the density slider, what do we expect? We expect there to be a lot more links. And sure enough, it looks like there are. And if we go down here and verify it, there are, right? Now, as I mentioned, when we built the preferential attachment, it's ignoring that density slider. So as you can see, even though the density is high, we're only getting 49 links, right? And so it's kind of a quick way to double check to make sure your code is all working properly. Now, one of the nice things about a preferential attachment network is it should be forming kind of a hub and spoke type structure, right? That's one of the kind of hallmarks of preferential attachment. But we can't see it right now because our agents are kind of scattered all over. So one thing you often want to do when working with network structures is add some code to kind of lay out the network structure a little bit better. And there's a bunch of commands that are built into NetLogo to work with springs. And these aren't part of the network extension. These are just standard commands. And so one of them, for instance, is called layout spring. So we can look it up in Google real quick. And you can see that it's going to arrange the turtles where basically the idea here is that the links are springs, and it kind of positions them accordingly based upon that, right? And there's some detailed description of exactly what we mean by that, but this is a standard algorithm for laying out networks. And there's a bunch of other ones, actually. If you go back, if I'd gone back, right, we could go to just look at the layout algorithms, right? And there's layout radio, layout spring, layout tut as well, right? So anyway, so layout spring takes a turtle set, a link set, spring constant, a spring length, and a repulsion constant. So they're all kind of a bunch of different parameters. You know what I tend to do? I tend to just copy and paste from the documentation. In fact, I copy and paste this whole thing, repeat 30, layout spring, et cetera, right? And so I can grab it and go over to my model, right? And just before I do the ticks, I can paste it in, and this will lay out the model, the network a little bit better. If we hit setup now, you can see that we kind of can see a little bit more of the structure, right? And it works for the random model too, right? The random model is going to be very tightly compacted. If we do this, it's going to be a little more open, right? But if you ever want to actually see it kind of doing everything it's doing, right, you can also just copy and paste again, turn down the slider, right, and put it in the observer, and you can see them kind of moving a little bit, right? And in fact, for this layout, it looks like maybe we would have wanted to lay it out a little bit more often. But anyways, let's double check to make sure the diffusion's still working correctly. Set up and go. Oh, let me speed that up, right? Set up and go, set up and go. Seems to be working. And, is there a difference between the networks? Maybe, I've got the densities roughly similar. It's a little bit slower for the, we can put the density down for random, right? So this happens every now and then, and we'll talk about that, but this is kind of a nice little error dimension. In this particular case, right, we actually generated an agent. There are some agents who are not connected to the network, right? And so we can either just ignore that, like I'm going to do now, and just rerun the model again. Or a better way to do it would be to have the social influence go to 0 if you were not connected to the network. And I will leave that as a homework assignment for you to work on, okay? Okay, that's it for this model. And when we come back, I'm going to talk about what I want you to do for Model 7. See you then. So in Model 7, I want you to extend the model again. And this time, I want you to create new types of agents in the model, right? So in the current model, they're basically all agents are the same in terms of their behavior. They do the same things. But what I want you to do in Model 7 is to create a new type of agent called an influential, right? Now you can think of, there's a standard kind of view that there are influentials and imitators when it comes to diffusion, right? Especially innovation diffusion. And so what we're doing is we're kind of adding in this influential notion, right? But obviously influentials have to be different somehow than the other agents, right? And the way the influentials are going to be different is that they're going to have a larger level of influence over the other agents, and those other agents are going to have potentially less influence over them, right? So I want you to add a weight that controls how influential influentials are, right? And then the other thing we're going to want to do is now plot the adoption of each agent type separately from each other, right? So that's the goal for Model 7. You could think about doing this in a number of different ways, and I recommend kind of taking a look at maybe some of the code that is out there that allows you to control different agents, and in particular, something we haven't talked about yet, which is breeds. And breeds give you the ability to have classes of agents besides just turtles. So you're not always talking about turtles. You can have different types of breeds within your turtles, right? So take a look at the breeds explanations, and when we come back, I'll show you how I did it.